With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, let's take a question. So here the question is the equilibrium constant Kp for the decomposition of gaseous H2O that is given here is related to the degree of dissociation alpha at the total pressure by. Okay, so here we will solve this question. So here first we will consider the equilibrium expression, that is we have H2O gas and here we have is H2 gas plus here we have half O2 gas. Okay, so here we will first have the initial moles. Here we have initial moles 1, here 0 0, right? And then when we will have the equilibrium moles. Okay, so here our equilibrium moles will be 1 minus alpha. Here we have alpha, here we have alpha by 2 because here we have half O2. Okay, so now if we calculate the total moles, if we calculate the total moles, then what we will have is 1 minus alpha plus alpha by 2. Okay, so here it will be is equal to 1 plus alpha by 2, right? Alpha will be cancelled. Now here, okay, here we have to consider or we have to assume that the 1 mole, when we have the degree of dissociation, okay, we will consider 1 mole whenever we deal with the degree of dissociation. Okay, so here the equilibrium pressure, at the equilibrium the partial pressure of the gas can be calculated. Here now we need to calculate the partial. Okay, first we have said that it is convenient to consider 1 mole, okay, whenever we deal with the degree of dissociation. So here partial pressure is equal to mole fraction, okay, into the total pressure, into total pressure. Okay, so now here when we have is the partial pressure of H2O, then we have is 1 minus alpha upon 1 plus alpha by 2 P. Okay, P is here our total pressure. Okay, P is here our total pressure. If we see 1 minus alpha are our moles for water. Okay, 1 plus alpha by 2 are our total moles, because here our mole fraction, here we have mole fraction of water, that will be equal to moles of water upon total moles that we have written here. Okay, so now after this step what we will have is the partial pressure of H2O. Partial pressure of H2O is equal to 2 into 1 minus alpha upon 2 plus alpha into P. Similarly, we can calculate for the H2. Okay, so here it will be alpha upon 1 plus alpha by 2P, that is 2 alpha upon 2 plus alpha P. Okay, and when we have is the partial pressure of O2, then we have alpha by 2 and we have is 1 plus alpha by 2P. So here it will be alpha upon 2 plus alpha P. Okay, so now we have the law of chemical equilibrium, and when we consider the law of chemical equilibrium. Okay, so according to that law, what we have is that the value of Kp is equal, will be is equal to partial pressure of H2 O2. Here we will have half. Here we will have half, because here we were having the half value, right? Okay, so that's why here upon it will be partial pressure of H2O. It will be like this. Okay, we can write it in the bracket to avoid the confusion. Okay, so it is like this. Now we have calculated these three values. So let's put up. Okay, for the partial pressure of H2, we were having 2 alpha upon 2 plus alpha P. For the oxygen, alpha P upon 2 plus alpha, here 1 by 2, and for the water we have 2 into 1 minus alpha upon 2 plus alpha P. Okay, so now here we can calculate the value of the Kp. Okay, so after solving this, here we have Kp is equal to alpha upon 1 minus alpha P. Here we have 2 plus alpha 1 by 2. Now finally we have the value of Kp required, that is alpha 3 by 2 p 1 by 2, because here we have 1 by 2 plus 1, right? 1 by 2 plus 1, that's why. So upon we have 1 minus alpha 2 plus alpha 1 by 2. So this is our required value for the Kp. Okay, this is our required value. So let's see the options. In the first we have alpha 2 incorrect, alpha 3 by 2 this, but here we have 1 plus, here we are having 1 minus. This is incorrect. This one is our correct answer. D is our correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.